We will now analyze another example of a categorical syllogism and show how to diagram it using Venn diagrams and to analyze the resulting diagram to see whether the argument is valid or invalid. So like our first example, we need to start by putting the syllogism into standard form, symbolizing all the statements appropriately. So first we're going to identify the conclusion, which in this case is some dogs are not Dobermans, because we see we have the conclusion indicator so our minor term will be dogs, and our major term will be Dobermans. And then the middle term will be what's left over, which is pit bulls. Then we write it out in standard form, so the conclusion will be some S are not P. The major premise will be whichever premise has Dobermans in it, so that's no Dobermans are pit bulls, so no P R M. And then the minor premise will be what's left over. Some dogs are not pit bulls, so some S are not M. Underline that. Okay, now we're ready to do the Venn diagram. So again, we're going to start with the universal premise, no PRM. So we want to shade in the whole area where P and M overlap. There's nothing there. That's what it says. If there are any P's, well, they're not also M's. In this case, if there are any dogs, then they're not Dobermans. Oh, sorry, they're not pit bulls. If there are any dogs, they're not pit bulls. This is, of course, false, but we don't worry about that. Okay, then we want to diagram some S are not M. Sorry, it was actually no Dobermans are pit bulls, which is true, but that doesn't matter. Okay, so some S are not M. So we want to put an X somewhere in this S circle that's not part of the M circle. So somewhere in this part, but we don't know if it should be in the part that overlaps with P or in the part that doesn't. So we have to put it on the line. So we put our text box right here. Write a nice big X. And we're going to make that box transparent. And do our line so that we can see. And let's see if we can scooch this over just a hair. Okay, that's a little better. Okay, close enough. Then we want to see whether the argument is valid or invalid by seeing if the conclusion is diagrammed here. So the conclusion is some S are not P. So there should be an X somewhere in this area. But there isn't. There's one on the line, but that doesn't count. It needs to be either fully in this area or in this area to count. So this argument is invalid. Okay, and what fallacy does it commit? Well, the major term is distributed in the conclusion, but it's distributed in the premise also. So it's not illicit major. The middle term is not distributed in the major premise, but it is in the minor premise, so it's not undistributed middle. It's not illicit minor because it's not distributed in the conclusion, so we don't have to worry about that. But we have here two negative premises. So this is the fallacy. It's called exclusive premises, which says that you can't have two negative premises, which is what we have here.